Hello and welcome. Today we'll be solving Leetcode 198 house robber. The question reads, you're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So here, without alerting the police, obviously making sure that you rob adjacent houses, which would be a great focus in solving this. Okay, so assuming we are solving this, right, and we start by robbing house 2, from the premise of the question, that would mean we cannot rob house 7. However, we can start to rob any of these houses down here, right? So assuming we rob 2 and go down to rob any of these houses down here, we have 9 and 3 again, and it's sort of like being in the position where we had a 2 and 7, making that same decision about robbing one of these. Let's say for the sake of this solution, we rob house 9, right? So that means we can't rob this house. However, we can rob any down here. Okay, so hopefully you're starting to see a trend. In the beginning, we are given 2 houses. We rob either one, and then we skip robbing the adjacent house, and from the adjacent house, any of the options left, we rob it and just follow that whole pattern, right? Now, trying to think of that can be difficult. So I want to provide some sort of like pattern or formula we can use to go about navigating how to solve this problem. Now, I want to say that the best way to solve this question is to obviously realize this pattern and write the code for it. So I'll help you see what that pattern is. So like I said, at the beginning, when we are given the array, we have the 2, right? And we want to choose any one of these and then skip its adjacent one and then keep doing that repeatedly. So now let's say we start from the perspective of 2, right? We are going to add 2 to whatever array is. In this case, 0. That'll be true for RB as well. That's just to help us with some base cases. And we are adding this number 2 to array because, like I said, we are trying to rob that house and all the adjacent houses that come before it, right? So the maximum we can rob by the time we are 2 would be the value 2 there, plus all the adjacent houses before it, which are represented by array, and just choosing to rob the house right by it, right? Which in this case is RB, and RB is 0. So between this, the maximum we can rob by the time we are here is 2, right? So it's either this plus this, or we just choose this, right? Let's keep going. So now we are going to be looking at things from the perspective of the house with 7. So we can either choose to rob this and the adjacent house before it, or just rob this. Now we know that up until 2, the most you can rob is 2. And actually, I should have done this before, but by the time we move to 7, this is going to be our new RB, and this is going to be RA, right? So from the perspective of 7, RA is still 0. Then we have 7, and RB will be the maximum number we have got so far from the house to the left of it, which in this case is 2. So from this, we know the maximum we can get is 7, right? So by the time you get to 7, the maximum that you'll be able to rob would just be the number 7, right? So now we are going to keep updating. And so now here will be RA, and this is going to be RB. Now we are looking at things from the perspective of 9. From the perspective of 9, it's going to be 9 plus what's adjacent to it, right? And realize that when we look at what's adjacent to it, we want to see the summation of everything you can rob from the house plus the adjacent houses before it, which we store down here, right? So that would mean from the perspective of 9, you can either rob 9 plus 2 or RB, right, which is now 7, right? So that would be 11 and 7, the maximum between that, which obviously is 11. Then we keep moving on. Now we are going to look at things from the perspective of 3. We can either rob just the one byte, which in this case is 11. Before I do that, I want to briefly point out that we will have updated these so that this is now RA, this is now RB. Now moving on. So from the perspective of 3, we can either rob what is right next to it or add what 3 represents, and then the maximum that you can rob from its adjacent house. So that would be 7 plus 3 and 11, right? Because as always is RA, which in this case is 7, and then the current number n, which in this case is 3, so that gives us 10, and RB, which is 11. So that means the maximum we can get by that point is 11, right? So the maximum we can rob by the time we're at 11, at 3, would be 11. Now moving on. So now this is going to be RA, and this is going to be RB. Now we are on the very last house, and the maximum we can rob would be whatever we've robbed from its adjacent houses, which would be represented by RB, which in this case is 11, right? Or the current number we are on, which is 1 plus is RA, but then the max that we have computed up to that point, which is 11, right? So the max between this would be 12. So for here, the maximum we'll have been able to rob by the time we're on the last one, and its adjacent would be 12, and we will just return this. All right, now you notice that before I did the analysis for this last one, I didn't update our RA, RB, which is starting to look kind of messy, but hopefully you're still staying. And you'd realize that as we keep doing this, by the time we get to the end of the array, it is going to be on RB. So when we write our code, we are just going to make sure to return RB. So yeah, hopefully this makes a lot of sense to you and makes the question a little bit easier to approach, especially when we understand how this formula works. So now we are going to go and solve the code. Okay, we are going to go ahead and solve and write the code for it. We are going to start by initializing the 2 variables I spoke about to handle the edge cases of if the array is just empty, is RA and RB, like from the figure before, and just like in the demonstration we'll give them the values 0. So now we are going to iterate through the numbers and store them temporarily as we do this computation. This computation will basically be the formula that I showed from our demonstration earlier, right? And realize that every time after we do this computation, we move array to go to where RB was, and we want RB to now represent the temp, right? So that we can just keep shifting the R and RB like I was doing in the demonstration. And like we said, by the time we are done, we expect that the maximum number would be on RB, just from that demonstration. And then we can run it. And yeah, we see that it works. It's a problem that looks rather very difficult initially, but when you understand how to approach it, especially realizing the pattern for it and being able to write the formula for it, then it becomes very easy. Thank you for watching this video. Please feel free to leave comments and suggestions. Just let me know how I can make the learning experience even better for you. Thank you and have a great day.